Welcome to this very last pre-recording of the 22nd session of MCS 260 in the 8-week summer session. So in this very last pre-recording, I will give some examples of questions for on the final exam, so in preparation of the final exam. So the example questions are meant somehow to highlight the most important aspects of programming. So programming is extremely vast and computer science is even larger. So programming plays an important part in computer science, but it's not the essence, or perhaps it is. But in this course, and for the final exam, so that's the main point actually, I will not ask for very large programs. It's mainly that you could demonstrate that you could reason about programs. Okay, important things first. So the final exam takes place on Friday, 4 August between 10 and 12. So being there is somehow important, not so much being there, but being available in that time slot. So the exam is as the course online. This course can be taken almost entirely asynchronously, but you have to be within this time slot for this course. If you have special accommodations and you haven't told me yet, then please try to do so certainly before the exam. Um, so that's also then the second important thing. So if you have something that prevents you from participation, we could do something. So there is no finals week here, so I copied this from an earlier semester course, but there might be something that can be done. If anything, if you are short on time, please look at the review, look at the notebook, look at the midterm exam. Even if you did the midterm exam, the other version might be interesting. And read the questions carefully. So even if this is now on the Python part, it may be that you are more asked for a design question rather than a code question. Um, you must format your answers in a Jupyter notebook. The questions will be emailed to you in two formats, PDF and Jupyter notebook. You could start a Jupyter notebook on your own, but if you do so, please indicate very clearly what questions that you are answering. Um, so, um, I could give you pseudocode or a flowchart and ask you to translate this. So you should also not only be able to write flowcharts, but also then certainly still be able to read them. So in the previous part, we had the opposite. Given a piece of pseudocode, write flowchart. I could eventually also ask you to, given Python code, write the flowchart that you can actually indicate the logic. This is an open book exam, but nevertheless, it's very useful if you can predict what the values will be. I can give you snippets of code. So the review is a little bit more elaborate. But the questions are a little bit longer than what you might expect on an exam, but that is because it is a review. So there are 6 questions. Many questions have several parts, and these parts could go to the different versions of the final exam. Okay, data structures. We introduced actually data structures shortly before the control structures. So lists correspond to loops, dictionaries correspond to branching constructions, so the if-else. Here is a question which transforms um, numbers and currencies in different formats. This is essentially a data format transformation question, which involves a dictionary and also string processing. Also, splitting a string on a space, you will have a list and you have to select from that list. So the purpose for this question here is illustrate how to define how a dictionary is used here, illustrate that how the dictionary can be used to convert from euros to dollars, from dollars to euros. So in both ways. And demonstrate that this actually works so that you can go in both ways. Um, what are the values of a program? If you look at this piece of code here, you have a function, a code snippet, a function without a documentation string. So what does this function do? What happens to the value? So we have letters A, B, U, V, and R. Which of these letters represent global variables, local variables? Um, what does this code actually do? What does it print? Um, Complete the table below. Um, so the slides were made from a time when we had paper and pencil exams, but as in the previous review on computer literacy, in Markdown it's quite simple to define a table. And please use the Jupyter notebook that you will receive to make the markdown table as well, so which then neatly formulates your answers. Working with files. In Unix, so there is this calendar command. I updated it to the calendar. So again, the important day. So the date of the review is Wednesday. We have our final exam that we can mark here. Suppose that this calendar is on file. So this is a plain text file. Design an algorithm that is actually going to give you the day of the week given the number. So if you are given 25, then it will return FR for Friday. I will give the solution in a minute as a complete Python script. Um, it is very important that this is your code and that you also actually describe the design of the algorithm. That I can see that the logic is properly yours. How you will work this out. This is extremely important, especially if your code would not work. List comprehensions, I have two questions on list comprehensions. We saw the estimation of pi via an area. You can actually also do this if you compute the line segments, the length of the line segments on a circle of radius 1. So the unit circle, if you compute the circumference of this circle, then you have 2 times pi. So the list comprehensions here prepare for that approximation. So in the first part, you have a formula given. Translate the formula into actual Python code. Use a list comprehension with this. And also this combines tuples. You have to know the use of the math module for the cosine, the pi, and you have to be able to translate this formula into working Python code. Um, the follow-up, so why would you want to do the previous exercise? Well, if you make your segments, or if you make your n larger and larger, so what we actually are going to do, we're going to compute the arc length, the length of the circle, by approximating the circle with a regular n-gon. And actually, if the n is large enough, we wouldn't really see the difference between the n-gon. Say if we use 1,000 points, we won't see the difference between the n-gon and the circle. So this is a nicer method to estimate pi, essentially, than what we've done with the Monte Carlo method. But the point here is not so much the particular method, but it's more that so here it's broken up into pieces. It is working with pairs of consecutive points. The formula is on the previous slide. So this is a typical review problem. If you don't know the formula, you can't really solve this problem. So in some sense, I'm here assuming that we have already solved the previous exercise. So in some sense, it's a good review problem, not so much a good exam question. Exception handling. The question here is to define a function which is extremely persistent. So each time the user is prompted for an integer, if the typecasting from the string to the integer fails, the user must be re-prompted. And that should be happening in a loop that uh, only exits, so the loop only terminates if there was no exception. Okay, GUI design. So in a way, this goes back to the first review question with the currency converter and the dictionaries. Um, I will give in a minute complete code. In some sense, this is pretty bad because the questions that are here are actually the design questions. When I'm answering this, I'm actually, so what you actually should be doing when you design a GUI, some people write documentation at the very end, very bad practice. When you design a GUI, you should actually first think about the widgets, and when you enumerate your widgets before you write the code, you should actually write this down in the constructor of the class that defines the GUI. So in the documentation, in the answer that I will present, you will see this, although I will give complete code for this question. It's important here that you know which widgets will you use. And you can also make a picture. So instead of the picture here, you could write the constructor. Um, and then there is the callback method, to the button that will do the actual conversion. Okay, so there are three parts, or actually two parts in this last review. The slide presentation with the questions, and I'm actually through with that now. And now comes the um, actual part. I have 6 review questions on Python programming. I have 2 Jupyter notebooks, so in a way I will show the answers to the questions immediately, which is in some sense bad practice, because you should not study the answers to the questions. You should actually look at the questions and try to see, recognize what will you do, and if you don't know it, how will you get to know it, referring to the lecture materials. Um, I should point out that if you are receiving the questions like this, here you are seeing the markdown table again. So Using this Jupyter notebook is very useful on having already, so you can copy and paste the markdown table and start filling this out. Please do so, or here you see also the design is important. I will give you essentially the code for it, which is in some sense not too good either. Um, Here are the list comprehensions. So this is a review question, more going towards an actual application. So the second part in the review comprehension is more to motivate why would you want to do something like this? Why would you want to generate your points like this? Um, Although this thing, so we had a project on making pie charts. So if you have a regular n-gon, a regular pentagon, this would correspond to a pie where all the percentages are equally equal to 20%. So that's one of the things we encountered these polar coordinates when we solved that project. The GUI design. So here are the questions. Again, these are 4 questions and they are happening in sequence. Good for the review. I could give you a screenshot of a design and then ask you for the code that actually realizes this design. I could give you the constructor and then ask for the callback function. So these are 4 questions. The first question is a design question again. So what type of widgets will you use and motivate the widgets? Why would you use the widgets? I will talk a lot. So the answers in the Jupyter notebook are simply code. I will try to talk about the code, and that should be the explanations why the code is the way it is. Okay, at this point in time, you could pause this pre-recording and start thinking about how you would solve these questions. If you have immediately already done this, or if you have a very good idea what the solution will be, then you can just compare your answers with what follows next. Okay, so here is then the Jupyter notebook with the answers. So a Jupyter notebook is extremely good to prototype programs. Originally, so this comes from previous runs of the course, originally all the answers for this review were in Python scripts. What you could do in a Jupyter notebook, you can intermingle the instructions, you can prototype the instructions. So, in order to convert from euro to dollar, from dollar to euro, you must have a dictionary that contains all relevant information. So, you have the uh, original currency and then the target currency, and then the table is symmetric, so you can convert euro to dollar, dollar to euro with the exchange rates sitting in there. So we have an example. So of course you could just do the computation. So the 135.8, so this is in dollars. So $1 is worth 91 cents in euro. So you can multiply this. That is the particular answer for this question, but you will have only a couple of points. And again, so this is, we are starting fresh in this second part of the last review session. This is an important question, so don't trivialize this, don't glance over this. This is the prototyping of a very useful program. So let me execute this. I have the input string. I split on the string. So what I find there, so I can of course read that I want to convert from dollar to euro. But here I have to select the dollar amount from the data. So I have the amount that I select. I have the currency, the input currency, which is here dollar, and I find the target. So in the dictionary, I have the currency conversion rate from the input, so it's dollar, so I'm going to look here. And what is the second part is a list. It could also have been a tuple, so that would not have changed anything. So there is not a unique answer to solve this, but this is a conventional one. So here you see how a program converts this dollar into euro. If I would change this, and that's actually the virtue of this Jupyter notebook, if I'm going to convert the input string is now in euro, so how much is €1 worth? Well, it's 1.10 dollar. So you will see that the conversion leads to something that's quite plausible, leads to a higher dollar amount. So this 149. You could play around. So you can see that this is a prototype calculation for a Python script. A Python script that will prompt for an input string, assuming here that the input format is correct. So the split, there is exactly one space, not two, or it's not, the space is there, there's at least one space, but not exactly one space. And you also see the format conversion to the proper fixed format with two decimals after the dot. Okay, the scope of variables in functions. So here you see a function, and of course you could run the function. So that could be, so that is actually just solving part 3, what does the code print. But you should be perfectly capable to actually solve this question without running the code. So in some sense, you can do it, and if you have time left, please do. It's always good to check your answers. But what is most important is that you recognize what are the global variables. So A and B exist throughout this code snippet. The U and the V, they are formal parameters, so they are not local, so just formal letters. What is a local variable is R. So we have seen that you could regard U and V as local variables. That's useful. It's useful if you look at the table because they have the same lifespan as R, but they are not local variables in the sense that there might not be an actual location for them. It might be that it's just that there is no actual, well, in this case here, there is an actual copy being made of these numbers. But they are not local variables. So here are the easy answers. Part 2 again is often, I remember now when grading the first midterm exam, that was a part that some students had wrong. So U and V are not local variables. Then the A gets replaced by the sum of A and B. So during the call, 2 and 3 do not change. The local variable R will hold the result of this update. And as an additional question, like on the midterm exam, I could ask, write now a meaningful documentation string for this function. So then I get an idea, have you understood what the meaning is of this function? Okay, working with files. In this Jupyter notebook, I have only essentially answered the Python code. So not the design of an algorithm. So how does the algorithm work? the algorithm is going to count the numbers in this list, and it's going to compare the numbers. So in some sense you compute, so you have 7 days in the week, and you are computing, you're connecting the numbers in the calendar, trying to see which column you are. So the first row after these names of the days, the abbreviated names of the days, you look where the first column starts, and any number that you then encounter, you have to correlate, you have to make the connection with the proper column. So we will read the numbers from file. You can read line by line. We will get the numbers from the file and check uh, how far we are with the number. So here is a better algorithm. We read the numbers one after the other until we encounter the input number. So we will read first the first two lines. We will actually essentially skip them. You could also split on these names, and you have the potential, there are 7 potential outcomes. Um, but you start reading on the third line, the numbers one after the other. You know that the numbers are separated by spaces, so you could read the whole line, or you could read, um, you also can use the, as I will do here, so you can use the character formatting. So you see that every column, every number occupies 2 spaces, 2 characters. You can cast, so you have to use the fact that they are cast, and as soon as the number that you're looking for is equal to the cast, the result of the cast of the string into the number, then you know that you can stop. So you have a count, and then you have to see which column you are. At the same time, you have to check the column. So the code is very involved. So I wrote the code once. So the logic, so we process line by line. So this is always, so I may also indicate, as I did on the midterm, read character by character or read line by line. Here I did not specify this. Okay. There are 2 different states. You start at the count equals 0, and it may be, so here this program, this snippet, this code cell here, it's actually an entire program, prints before it says done true. So if done is true, done is the flag. So I wrote this actually in many stages. I will not go through this here with you, but just execute. So I have the days of the week, and you see there is no explicit print at the very end of the code cell, but it has terminated by printing. So as after the print, it sets done equals true, and it breaks then out of the loop. It also will break if the dictionary is empty. So if the day was larger than 31 or was a negative number, then it would not have um, it would not have been um, a finite loop. It would have ended. You also see the typecast. So each time I'm actually buffering. So I'm reading the first, uh, I'm reading 2 characters at a time. So also here, I'm reading 2 characters at a time. So with the K, so there are 7 days. Um, so we actually are, so we are treating the first day of the week separately. So that's why uh, the code is rather, so I read here the beginning of the line, um, checking whether there are spaces in there. So the first line might be different. Um, so and we are skipping, so now in the count here skips the first lines, so it's only, so this is where the skipping happens, so we skip the first two lines, so the count must be larger than one, so the count counts the lines. And then inside, the line is processed in segments of two consecutive characters. Each time the number is cast. If it is equal to the day we're looking for, then we will print the day. Otherwise, we will continue. So the lookup with so the k, what you look it up with is one of the numbers in 0 and 6. All right, I explained the algorithm in words. It would be a good exercise to draw the flow chart of this. So the logic is kind of convoluted. So I wrote this program a very long time ago. It also takes me some time to understand the logic. We process line by line, skip the first two lines, and then process each line. Each line is a sequence of characters in segments of slicing from the line, essentially. So here we process the first two characters, then we actually go in segments of three. So then we take three steps each time, exploiting the fact that every in the calendar we exploit the format. You could also split on the spaces and convert then. So that's an alternative format. So you can convert this into a matrix as well. But here I needed to know in which column I was. So the k is an important parameter. That's the column. That is the key in the dictionary as well. So there is not much documentation here. There's actually no documentation. But the names of the variables can be given a specific, uh, this is a good meaningful name. All right, list comprehensions. So here you see the sequence of corners of the regular n-gon. So we have the formula that is translated into a list comprehension. So here I import the cosine and sine and pi. The points, I have 8 points. So in some sense, I would need to go one step forward to go back to make the full circle. So let me illustrate this. So I end at 1, 0 again. So um, this makes this essentially shows the correctness. Although if you, so this is a regular 8 gon, so we have pi over 4, and you may recognize the square root of 2. Also here you have the 0, 1, so there is this 10 to the power minus 17, which is close to 0. All right, this was a very simple list comprehension, which could be typical for um, um, a final exam. Why is this question relevant? Well, we estimated pi at a very mainly using Monte Carlo, which is for this problem not a good problem. Here you see a much better estimate for pi, where we take the same points again. So these are the tuples. And then we take pairs. So here it is important that we select the current and the next, but then for the next we must be careful not to go over. So that's why I here NBR minus 1. So this gives us the pairs. We make the vectors because we need the length of the line segments. The length is computed in here with the square root. So in the differences here for every tuple in the pairs, we compute the length. And that will give us an approximation. If you are really concerned with the accuracy, now here actually might be a good way. This will be leaving out the last segment. So you may want to start here with NBR plus 1, and then you can leave off here the NBR. So a regular n-gon has as many segments as there are points. So the first and the last point here I take the same. So here I have a better approximation. So this is a more correct solution for this 2 pi, a better approximation of 2 pi also. All right, let's go to our persistent prompter. So we want to prompt which will continue prompting as long as the cast of the string, the input string, so when you ask for an input, it used to be a raw input in Python 2. That's why the name is int raw. So it's, if you look at the input, it could contain a string, but it's actually a string still. So the cast here is done in this try except block. So we have the specific name, so it's the value error when the cast fails. So if I run this, I prompt for an integer. If I type in a character, so x, then it failed. If I type in a good number, then you see that it succeeds. So at the while true, I do the return of the number, so that causes me to break also out of that loop. Okay, exception handling is important for robust programs. So to conclude, let me talk about the last question. So the answer is actually the complete GUI design, the complete GUI. But the question is actually on GUI design. So what kind of widgets would you use? Well, the user must be able to type in any amount. You could ask to do the dollar. So we have done the first exercise. So actually with the dictionary we could do it. So the minimal design would be one entry widget for the input currency. Then the button that would then display in a text variable label. You can have a label with a text variable as we have seen, or you could use another entry widget where you put it in. That's a minimalistic design, 2 entry widgets and a button. Now we can do this, but then it might still be not so user friendly. If the user mistypes dollar or euro, then we may not know what to do. So in the design that I'm presenting here, there should be a checkbox for type of currency, dollar or euro, so that the user should only type in a number. And that's much easier to make robust. If there is not a number in there, then you can give an error, you can display an error. Okay, so let me show the design now. So here you see the answer, what I just said in the design. So the layout of the currency converter consists of a first entry widget, which will contain the amount that needs to be converted. There are two check buttons to check the conversion type, and there is one button to then for the user to press to do the conversion, and the result will be in the second entry widget. You could also alternatively, if you are really want to be economical with space, you could have one entry widget where in the result you would confirm the input. You would say that many euros equals that many dollars. So that's an alternative design. So there's not really a unique answer. Um, The code, so I could give you the design. So this could be the input of a question. Give the code for the constructor, which has two entry widgets, two check buttons, and one other button. Don't worry about the commands. So here you have the uh, check buttons. So there is one variable which is the currency, which will either be one or two. Um, so um, there is the grid. So the layout of the grid. You could think left to right. That is fine. You could also think top to bottom. But the top is typically the input then, and the left would also be the input. All right, given the constructor, you could be asked for the callback function. So the callback function gets the amount from the entry widget. Um, so here then you should recognize that amount is the name of the entry widget. So there is the get method there. You can insert into an entry widget, so there is the result at the end, and in between there is the conversion. In this GUI, I wasn't so specific about this, so the conversion rates are here just constants in this program, no dictionary. Okay, so I will end by demonstrating this. Let's see, how do I do this? I have to add the window to this. So here is the window. So there is the euro or dollar. You see, I have been able to work with exclusivity, so the user can check only one. So in motivating why I work with this checkbox, so you can check only one. Uh, this has the advantage of working with these integer values. So you could have multiple check buttons if it makes sense to check multiple them at the same time. So let me convert euros. So here you see the conversion of the currency. So in some sense, the result, if you want for a more economical design, you could actually recycle the input window. But it's probably, so let me verify if I convert back, then indeed $132 is 120. Interesting. So let me redo this. So 120. There is still a round of error somewhere in this program. Okay, but you get the point. So this exercise is already good for a review. It might be too extensive on a final exam. So the code that you will need to write will not be much longer than a function with no more than 10 lines in it. Okay, so this was the last pre-recording of this course. I hope that this pre-recording prepares for the final exam. Again, very important the time and the date. So if there is something happening that prevents you from doing this final exam, please contact me. It is mandatory to pass the course. And if you're pressed in time, please review at least this review, or look at the format in which the answers should be submitted. Again, in the second part, most of it was code, but half of the questions, at least half of the questions on the final exam, will actually ask you to explain something, to demonstrate that you have understood what we have covered in this course.